Right, wonderful people, let's continue, and now we are in question 4. They say a plastic company in Johannesburg produces baskets using a synthetic rubber. It starts by processing the synthetic rubber into a cylindrical bucket without a lid. For example, it is opened at the top. Of height 80 centimeter and base radius 20 centimeter. So it is a cylindrical bucket. So let me try to do that. This is the base, which is also circular. We are given the radius of 20 centimeter, and we are also provided with the height of 80 centimeter. Right, and they say calculate the total surface area of the cylindrical container if the surface area is equals to this. So fortunately the formula is given: pi r squared plus 2 pi r h. Now remember, this is pi r squared because it is opened at the top. So because if it was not, we would say 2 pi r squared, because we would have two circles, top and bottom. But because it is opened on the top, we are not considering the other circle, because it has to be 2 pi r squared plus 2 pi r h. Okay, there's a common factor that can be taken out, which is pi r, and then I will have r plus 2h. Let's check if this is true. This is pi r squared plus 2 pi r h. Right, and then from here let me see the value of pi which they use, if it is provided. It is not provided, so we're going to use 3,142, or just insert pi on your calculator. The radius is 20 into 20 plus 2 times height 80. Right, and then from here let's see what value we would get. So I would say pi multiplied by 20, open bracket, 20 plus 2 times 80. So I get a value of 3,600 pi. Remember its surface area, that would be centimeter squared. Right, somebody might want to write this in decimal form. That would be 11,309.73 centimeter squared. Okay, 2 marks are provided for that. Let's go to 4.1.2. To convert the cylindrical container into a cylindrical bucket, a special machine is used to cut off 900 square holes. So we have 900 square holes from the surface area of the body of the container, while the base of the container is excluded from cutting. So this part is not being cut. Only 900 holes of the sides, excluding the base, which is in a circular form. Right, let me continue in this. Calculate the total surface area of the bucket if the dimensions of the cut square holes are 2 centimeters each. Now listen to the question. Calculate the total surface area of the basket if the dimensions of the cut square holes are 2 centimeters each. So let's calculate the total area of these square holes. So area of square holes, because they are in a square shape, remember 900 square holes, and the area of a square is side by side, and we are given that square holes are 2 centimeters each, right? So that would be, remember how many there are. So the area of just one hole would be 2 by 2, which is 4 centimeters squared, just one hole, but there are 900 of them. Very important. So let's see what value we would get. 900 by 4, and that would give us 3,600 centimeters squared. That would be the total area of those square holes if each is 4 centimeters squared. Right, now remember what the question said. It said calculate the total area of the basket now if the dimensions of the cut square holes are that. So we are going to say total surface area is equals to 11,309.73 centimeters squared minus 3,600 centimeters squared. Right, and what value will we get there? 11,309.73 minus 3,600, and we would get 7709.73 centimeter squared. That would be the value that we get there. Right, that is fine. And then we go to 4.1.3. Calculate the volume of the container in 4.1.1. Right, the volume of a container. Right, let's go and check. The volume of a cylinder is pi r squared h. Pi, the radius is 20 squared and the height is 80. Now let's see what would be the volume in 4.1.1. Right, this would be pi times 20 squared times 80, and that would give us in decimal form 530.9649 centimeter cube. Right, now let's go to 4.1.4. Do you think the volume of the container in 4.1.1 should be the same as that of the basket in 4.1.2? Substantiate your answer. Now let's check. Do you think the volume of the container in 4.1.1, where is that? Here it is, the volume. Okay, do you think the volume of the container in 4.1.1 should be the same as that of the basket in 4.1.2? the volume. Substantiate your answer. Now remember the volume. The volume talks about that, how much that should be contained inside, whereas area is the amount of space that something can occupy. So the volume tells us how much can fit inside there. So they are saying, do you think the volume of the container in 4.1.1 should be the same as that of the basket in 4.1.2? Yes, the volume should be the same. Remember, yes, it should, because remember, the height is the same and the radius is the same. Yes. So I'm going to say yes, and just looking at the dimensions, there is no change in the dimensions. The height remains the same and the radius remains the same. Therefore, the volume should be the same. Because remember, in 4.1.2, what we did was just to calculate the total surface area. Remember, so we subtracted the area of those squares to the original area. So that has nothing to do with the volume. The volume should be the same because the height and the radius are the same. You would give your own reasons there. I don't have time for writing. And then I would go to question 5. Things are getting very interesting in question 5. We are dealing with functions. You might want to go and look at my tutorial where I deal with Thomas, the 12th edition, where I explain the functions and everything in them is. So in 5.1 we have the following. Given the function f maps into y minus 15 minus 8x minus x squared, I can just rewrite this. Please be careful. I can say minus x squared minus 8x minus 15. Just rewriting this in the correct quadratic format. And then let's continue and see what they are looking for. Right, in 5.1.1 they say determine the y-intercept of f. Right, how do I find the y-intercept? I know that y-intercept x is equals to 0. So y equals minus into 0 squared into 0 minus 15, which is minus 15. That would be the y-intercept. The x-intercept, y is 0. 0 equals minus x squared minus 8x minus 15. Divide everything by negative. You would get x squared plus 8x plus 15. You might want to factorize this. The bigger number takes the sign of the middle term. X equals minus 5, x equals minus 3. Fascinating stuff. And then 5.1.3, the axis of symmetry, x equals minus b over 2a. That would be, remember, from the original one. So that would be minus into minus 8, 2 into minus 1, 8 over minus 2 minus 4. Very, very good. And then we go to 5.1.4. The y ordinate of the turning point of f, tp equals minus b over 2a, which is the same as this. So what we would do there is to substitute this on the original. Therefore we would say f at minus 4, because they are saying the y ordinate. So that would be minus 15 minus 8 into minus 4 minus into minus 4 squared. Right, and then that would give us minus 15 plus 16 plus 16 is 32. Minus 4 squared is 16. Right, from here you just insert this on a calculator and you get your final answer there.